something that represents A, T, G, and C, correct?
Because it's not linguistic information. Braille is linguistic communication information.
And that's
so
why
we're back to codes can only be linguistic by your definition.
And by the way, I'm not arguing that DNA is a cipher, or I'm not arguing that this all is a cipher. I'm arguing that it could be a cipher, maybe a code in Luce's definition, but it's pseudocode, pseudo cipher. It's not really one or the other in many ways.
Yeah. I'm arguing that the genetic code. Okay, go ahead. I'm arguing that the genetic code. That is a code. The genetic code, that codon chart, the set of rules that govern the way that the genome communicates with the ribosome, that code is a code in exactly the same way that binary code is a code. It is a code according to the rules, according to the definition by Claude Shannon.
Okay.
All right.
Okay.
Now it's up to people to go look into this and decide for themselves. I think you're close there, Shannon. I have to agree with Shannon. I like the way she gave her final thing on that. I think you got it pretty much. So
I do. Yeah. Well, I guess. Sure. All right. I'm still not clear on when it stops being a code or if it is, but I appreciate both of you.
It depends on what you mean by stop. What do you mean by stop? Because there's.
Well, he said that he agrees that the letters. He agrees that the letters on the RNA sequence are a code, right? The letters are a code.
What do you mean by letters? Define letters.
Or U in this case, the RNA, because obviously you don't have T in RNA. Yeah, that's a code.
So the letter sequence on the RNA as it goes through the ribosome, that is a code. So the letters themselves are a code.
No, nothing going through the ribosome is a code.
They're not. No. The letters on the RNA. The letters on the RNA are a code. Are they not?
Well, hang on one sec. There's actually no letters on the RNA. They're chemicals. They're nucleotides.
Yeah, I
right?
understand.
The only thing letters on a piece of paper.
That the letter G isn't written on a goddamn RNA.
I know, but that is such a. That's why the language is so loose. That is why we have these issues, because language is so poor for these types of things.
Guanine is on RNA, right? Am I wrong about that?
Yes, the chemicals on there. Yeah.
Okay, so we'll stick with that. Guanine, right? Okay, so that's one of the chemicals that's on RNA, right?
Yeah, that's one of the nucleobases.
You agree that is a portion of a code, at least?
No,
is it not? It's not. Okay, well then
the
what
symbol
did you earlier?
The symbols.
Okay.
If you look at symbol A, T, G, and C, those symbols. That's the code. The symbology.
So those symbols are us transmitting. I get what you're saying now. So those symbols are us as humans giving a letter representation. A symbol. Let me finish my sentence so that I can actually agree with you, Steve, for the love of Jesus. So that letter is us as humans giving that chemical a symbol so that we can transmit the information that represents to ourselves. So the chemical itself is not a code, but when we translate it into those letters, it becomes a code, because that's something that we use to understand how that works. It's just a translation. Yeah. Okay. I understand.
What's happened
is a code for water. Right. That's a symbol.
No. Okay. So what's happened here? Here's where you're confused. If you pull up my slide again, if we can actually look at the genetic code, you could actually draw this by, instead of drawing CUU, you could actually draw those three nucleotides instead. And then instead of doing the amino acid LEU, you could actually draw that amino acid. So if we were to replace these with actual drawings of those things instead of the letters, what would that do for you?
Well, you mean
we would actually draw out the molecule.
The amino acid. The amino acids have the same basic structure, right? It has a COOH and the NH2, and then it has your R group, right? Your residue, right? So they're all amino acids are the same thing, except the residue changes, correct? They're on the same basic structure, right?
Amino acids have a different amino acids have different side chains.
The side chain, which is your R group, is your residue, right?
Yeah.
But the other structure, the NH2 and the COOH on amino acids are exactly the same. All amino acids are identical except for that side chain, right? And that's what changes. Okay. That's one of the reasons why proteins fold the way they do.
You're not answering my question. Just listen to my question here. If I were to draw this exact same chart, but instead of using letters, I used actual drawings of each molecule, what would that do for you? Would that make this no longer a code?
Yeah, that's just.
So you're saying that
picture.
You're saying that this is a code. You're saying that this is a code because there's letters on it. But if I swap those letters out with drawings of molecules, would it no longer be a code?
Yeah, because again, a code has to have conveyance of a meaning, right? And like a word.
Yeah.
Like again, my example with the car and nuclear weapon. Car conveys a meaning to nuclear weapon. Just a symbol. That's more of a cipher than anything. You're dealing with. You're taking one thing and you're converting it into a different symbol. That's a ciphering. That's how I look at it.
Do you speak more than one language?
Yeah, language is not a code, but I know I speak a little
more
Spanish.
Than one language. Okay.
I know a little.
So you seem really hung up on what a symbol can be. A symbol doesn't have to be a letter. A symbol can be anything.
I understand that.
An apple.
An
apple can be a symbol.
Yeah, I get that. In a code.
All right, listen.
Steve, let him finish.
Yes, you have to let John finish his thought. He is very patient and lets you finish your thoughts. Just let him finish his thought and stop interrupting him, please.
Yes.
John, go ahead.
In the genetic code, molecules are used as symbols. The codon, the 3 molecules, do not actually represent serine, the amino acid. They are not actually serine, the amino acid. They are a symbol for serine that the ribosome understands. The ribosome receives that, and I'm going to anthropomorphize a bit here. It says, oh, I need to grab a serine. And so it grabs a serine and it adds it to the protein chain. Now, of course, you and I know mechanically how that all works. But the codon, the 3 nucleotides, act as a symbol in this communication system. And this chart shows us the rules that it shows us what all those symbols mean. But they are symbols.
I think you're just wrong. I think you're just wrong on that. You're just. I think all you're doing is you're saying these are my instruction sets, and I'm calling that a code, and that's not what a code is. Instruction set is not a code unless you're looking at the actual, like an assembly, like CMP or JNZ. Those are a code because that's the symbology that represents something else, right? And the fact that they're rules, that's not the code. The rules are not the code. I mean, maybe in a legal sense, but this is not even a legal sense.
So I think in a Claude Shannon sense, he literally describes it that way. Like, by Claude Shannon's definition, a code is the set of rules governing a communication system.
Yeah, I think he's using it a little bit different way than you think. But anyways, that's my presentation, and we'll let kind of people go from there.
All right, I think that you guys aren't going to agree.
Well, I don't know how many times I could tell him that I think he's equivocating.
It's becoming circular. It's becoming really.
Yeah, we need to get hashtag Team Cipher and hashtag Team Code T-shirts made up.
Well, no, because I'm not claiming because I'm not arguing with the cipher either. I think it's kind of neither in the big picture. I think there's pseudo cipher or pseudo code. I think that we have. I said this earlier. I think we have limitations in the English language.
Less than when Q.
I think we have limitations in the English language that prevent us from adequately describing certain things. And this is one of those cases where I think that there's limitations because there's so many different ways to describe something linguistically and from different fields that these words mean different things.
Let me just end by saying why I think this matters, because I think that's something that I haven't really said yet today. The genetic code, like all codes, is arbitrary. You could invent a cell that uses a completely different set of rules. This chart that we're looking at here would be completely different. You could create a cell that uses a completely different set. We've actually learned already that some organisms use a different set. So they already exist, even in nature. The genetic code is a set of symbols that the genome uses to communicate with the ribosome. What does it communicate about? It communicates about the structure of a protein. It communicates that across. It transmits that from the genome to the ribosome. The reason this is so important is that this communication system is complicated. Not only that, it's optimized. I didn't talk about the optimization of coding systems, but you can make any symbol mean anything if you are inventing a coding system. But some symbols, if you use them a lot, you want them to be easier to use. So in Morse code, for example, E, which is the most common letter ever sent in Morse code, in English at least, is represented by one dot. and they optimized it like that on purpose for ease of use. And the genome, the genetic code that we're looking at right here, this chart here, these are actually optimized as well. And they are optimized so that the ribosome doesn't misread things. The ribosome is not a perfect machine. It misreads things sometimes. And this is optimized in a way that it doesn't screw up when it's misreading. This is a complicated communication system, and we need an explanation as to how it arose. And people who are studying the origin of life are doing that, and they're spending a lot of time and a lot of money doing that. And that's why I think it's important to just disregard it and say, oh, it's not a code because some creationist made an argument that I don't know how to rebut. That's really silly. Like, this is a real code, and we want to understand where it came from. We want to understand how it evolved. And people studying the origin of life are trying to do that right now. There's researchers working on that. So,
let me reiterate here that this has nothing to do with intelligent design. I'm not an intelligent design advocate. I don't give a crap what their arguments are. I will go after people for bad arguments, whether they're intelligent designer, atheist, theist. It doesn't matter to me. I don't think this has anything to do with intelligent design. So if they're using this for their bad arguments or whatever, that's irrelevant to what I think, right? And so I don't know why that straw man keeps getting brought up. If intelligent design,
I'm bringing that up because people keep saying it online. Every time I hear the argument that code's not a code. Yeah, but
it's not a code because it's not a code. It has nothing to do with the idea.
90% of your listeners are it's because of that argument. Genetic code is a real code.
One sec. I think atheists, as well as I think they make a lot of bad arguments, right? And I call them out on it all the time. So it's not like I'm afraid to call the atheists out for bad arguments. This is not a bad argument by them. It's not a code. I disagree with you on that.
Can I ask one question?
I don't think it's atheists. I think it's biologists. We'll call it not a code.
You disagree?
In the true sense.
What? Steve, what is it then? If it's not a code, concisely, what is it?
It has elements of both, depending on what definitions you use from what field.
Oh, dear Lord Jesus.
What is it?
That is
It's DNA.
I'm sorry.
It's a chemical. It's a macromolecule.
It could be comprised of different elements from other places, and you say that he's wrong for using it from another place. That doesn't make sense.
Does everybody here know what plain text is? Does everyone here know what plain text is?
I have no idea. I don't know.
Because I got some plain text for Steve and John. There's 2 minutes left before 10 o'clock Eastern time. That's how much time you have left on my machine. That's plain text.
Yeah. Well, David is putting us on timeout.
Well, no, let me just use that minute.
We're not going to cut it off at 10. Hold on. Let me interrupt. We're not going to cut it off at 10. We're going to go until we get we get our thoughts out.
I'm just playing. I'm just making a joke.
Like I said, I think it's just physiochemical reactions. I think that DNA is just a macromolecule that has the ability to produce proteins, and that's all through conformational changes. And that's what the information is that I think Shannon even refers to is that there has to be some kind of intentionality there. Shannon, if I remember correctly, doesn't mention, he either says intent or intentionality. That's a critical thing because there is no intent, there is no agency, there is no intentionality in things like ribosomes, even in a teleological, excuse me, a teleonomic type thing. There's no agency there. And yes, agency requires some kind of consciousness. That's literally what the word means, to be able to change your brain state to decide. There is definitely information. Yeah, absolutely.
There's information that's being translated into proteins consistently.
Yeah, the information is what's required.
The same sequence will be translated, for lack of a better term, into the same proteins consistently. But that's you can understand how it's complex for me to not understand how that's not a code when it's consistently translated into the same thing. Information, arbitrator that translates that information, output consistently the same. Right? Information, something that translates that information, output consistently the same, but not the same as the information.
But the information is not the code.
But you don't know what
not a code.
Okay.
No, I do know what I do know what information is. Information is what's required to describe the state of a system.
And that's why Shannon gets. That you don't. I'm just like, I don't understand why it's not though. Like, and you could for a layperson like me, this seems like semantics.
It's not.
But you can't tell me what it is. It's not a code. It's definitely not a code. What is it?